We're all pretty much swimming in a giant ocean of data. But how do you take that chaotic flood and turn it into something you can actually build with? Well, that's where the data architect comes in. They are the master planners of our digital world. They're the ones who draw the blueprint that transforms all that raw data into powerful, usable insights. So let's dive in and see what that really means.
So here's our game plan. We're going to start by looking at the architect as a data city planner. From there, we'll check out their blueprints, see how they choose their materials, understand the rules of the system they create, and finally, see how they build everything to last for the future.
All right, first up, the data city planner. Just think about it for a second. Most companies today are just drowning in data coming from everywhere, and without a solid plan, it's just pure chaos. The data architect's #1 job is to step right into that mess and bring order, a clear vision, and a structure that actually works. To really get our heads around this, let's ask a really simple question. What is the actual difference between a messy pile of bricks and a towering skyscraper?
The answer? It's the architecture. It's that intentional design, the blueprint that turns a bunch of raw materials into something valuable and functional. And in our world, data, that's the bricks. The data architect provides the plan that turns all those bricks into a skyscraper of insights. And this really gets at a common point of confusion. You see, a data engineer, they're like the construction crew. They're on the ground, building the data pipelines, laying the pipes. But the data architect, they're the city planner. They design the entire grid, deciding where the roads go, where the power plants are, and how the whole ecosystem fits together. Okay, so if they're designing the whole system, what does that master plan, that architect's blueprint, what does it actually look like? Yeah, this role is so much more than just coding. The architect is thinking at a super high level. They're doing enterprise modeling, figuring out how all the different pieces of data in a company relate to each other. They're deciding the platform architecture, like, should we build our data city in the cloud? And maybe most importantly, look at that last one, collaboration. They have to work with everyone, from the business execs to the ML teams, to make sure the blueprint actually serves what people need. So here's a pretty standard layout, kind of like a map of our data city. It all starts over on the left with the source systems. These are the factories and stores producing all the data. That data then flows into some kind of raw storage, it gets cleaned up and processed through pipelines, then organized in a central hub like a data warehouse, and finally, it's ready to be used by the analytics and machine learning teams to make smart decisions. This is the city's core infrastructure. So we have the blueprint, we see the layers, but what are we going to build this city with? That brings us to choosing the right materials. An architect has to pick the right technologies from a toolbox that is just massive. And one of the first, most fundamental decisions an architect has to make is this one. For that central hub of data, do you build a data lake or a data warehouse? They sound similar, but they serve totally different purposes, and picking the wrong one can be a huge mistake. A data warehouse is kind of like a pristine, well-organized library. It's built for structured, clean data, and it's perfect for things like business reporting. A data lake, on the other hand, is more like a giant reservoir. It's designed to hold everything. Structured data, sure, but also all the messy, unstructured stuff like text, images, and videos. It's this massive pool of raw potential that you can tap into for all sorts of things, especially machine learning. But what if you need both? I mean, who doesn't want both? Well, that's where the modern solution comes in, the Lakehouse. It's a hybrid platform that gives you the best of both worlds. You get the massive, flexible storage of a data lake combined with the powerful, structured analytics of a data warehouse. It's a real game changer. A city isn't just buildings and roads. It needs laws, it needs traffic lights, and it needs a way for things to get from one place to another. This brings us to the rules of the system, data governance and integration. Data governance can sound a little boring, but it's what makes the entire system trustworthy. The architect has to define these rules. Who is actually allowed to see sensitive customer data? Can we trace this sales number all the way back to its source to make sure it's real? Can we actually trust the data we're using? Answering these questions is what separates a functional data city from chaos. All right, so we've got the laws of the land, but how does the traffic, the data itself, actually flow through our city? How does it get from the factory to the warehouse to the storefront? This is where the different integration methods come into play. For instance, ETL is like the fleet of big trucks that move huge batches of data overnight.
Then you have something called CDC, or Change Data Capture, which is like a live newsfeed, instantly broadcasting any change that happens. And then tools like Kafka, that's the city's high-speed subway system, moving millions of tiny data points in real time. The architect has to pick the right mode of transport for every kind of data. And finally, we get to what might be the most crucial part of the job, building for the future. A great city isn't just built for the people who live there today, it's designed to grow and adapt for decades. A great data architect has to think the exact same way. So how do they do this? They use all these clever techniques to make sure the system can scale. Partitioning, that's like opening up more checkout lanes at a busy grocery store to handle the rush. Caching, that's like keeping the milk and bread right at the front of the store so people can grab it quickly. These aren't just technical details, they are strategic architectural decisions to make sure the whole system doesn't grind to a halt when data volumes inevitably explode. And this right here really gets to the heart of the role. Technologies are always changing. The hottest new database today could be totally obsolete in 5 years. But a truly well-designed architecture, a solid blueprint based on smart principles, that's something that will last. So when you boil it all down, the ultimate job of a data architect isn't just to pick the right tool for today's problem, it's to build a foundation so strong that the organization can keep building on top of it for years, maybe even decades to come. Their real challenge and their real value is to think in decades, not just deployments.